Hey guys, today we are going to check out how we can solve quadratic inequalities such as this or even this. So if you are ready, let's roll in the opening intro. A quadratic inequality is an inequality with a quadratic expression on one side and 0 on the other side, and it generally involves one variable, something like you see in the screen. Questions may go like this: solve the following quadratic inequality, and what this essentially means is that we need to find the range of values of x that satisfies this particular inequality. The first step is to expand and rearrange the expression into the form of ax squared plus bx plus c, keeping 0 on the right hand side of the inequality. This will give us 2x squared minus 5x minus 3 is more than 0. Step number 2, we will factorize this expression as much as possible, which is in this case is 2x plus 1, x minus 3 is more than 0. Step 3, sketch a rough diagram. Now since 2x squared is positive, we are going to have a smiley U-shaped quadratic curve. Draw a line which represents the x-axis. In scenarios where you solve this equation, the roots are actually -½ and 3, so we mark down these values on the intersection points. Step 4. Look out for the inequality sign over here and solve the inequality. This is a more than sign, which indicates that the ranges are located in the positive y region, over here and here. Now, don't ever shade this region, because if we project a vertical line in a positive y direction, there are actually no values of x from this curve that corresponds to it. Thus, we only shade these regions to the left and right of the curve. So since the shaded regions are on the left and right respectively, x is less than -½ or x is more than 3. Now let's look at questions that involve a less than inequality sign, such as this. Remember step 1, expand and rearrange the expression into the form ax squared plus bx plus c, keeping 0 on the right hand side of the inequality. And this will give us x squared plus x minus 6 is less than 0. Step number 2, factorize as much as you can. This will give us x plus 3, x minus 2 is less than 0. Now, the next step is to sketch a rough diagram. Notice that this is a positive quadratic equation, so similar to the previous example, we draw a smiley face and label the intersections as -3 and 2. You notice that the inequality sign is a -1, so let's look at the negative y region over here and shade this particular region. Now, don't ever shade this region, because if we project a vertical line in the negative y direction, there are actually no values of x on the curve that corresponds to it. In this scenario, it gives us a combined inequality since the ranges of x are encapsulated within this shaded region. So -3 is less than x is less than 2 will be the answer. Now just a bonus tip for you, if the inequality sign shows less than equal in the question, all we need to do is to replace all this less than sign into less than equal signs. And the answer will be -3 is less than equals to x is less than equals to 2. Now we are going into solving combined inequalities, or range of values of x that satisfies two concurrent inequalities, such as this. Not to worry, the first step is to break them down into two separate sets of inequalities. Now let's solve the first part. 16 minus x squared minus 12 is less than 0, so we will have 4 minus x squared is less than 0. Now I would prefer the x squared to be positive, so let's multiply a -1 throughout the equation, and remember to change the inequality sign as well. Now, as we factorize, we will have x minus 2 and x plus 2, which is more than 0. Sketching the curve, we shade the outer regions. And for this part, x is less than minus 2 or x is more than 2. Now in the interest of time, I have solved the other part as well, giving us 3 less than x less than 4. Now with these two parts solved, we are going to find a common range that fits both these inequalities. We do this by drawing a number line. First, draw a line, and next, with all these values you have found, rank them in ascending order and place them on the number line. You need not draw this to scale. Now introduce arrows and label them to indicate the respective ranges. So for x is less than minus 2, for example, we denote this using just a circle and pointing it to the left. For x more than 2, we point it to the right, extending as far as your line can go. Now next, for the region 3 less than x less than 4, we denote it over here using a circle shaded dot to indicate that it is a less than or equal sign. And then what we do is to find a common region. Now in this case, we can shade the region below 3 less than x less than equals to 4 because these two ranges overlaps with the other, resulting in a common range or region that satisfies both inequalities. So the answer to this particular question will be 3 is less than equals to x is less than equals to 4. Now if you need further practice in this area, do check out the free downloadable practice questions and work answers that I've prepared, linked in the description box below. Wishing you success and all the best in your foundation building. Bye!